my voice is audible. I hope I can see that it is live right now from my side. Okay, so I am doing live lectures right now. I request please drop a message that my voice is audible. I hope it's audible, right? Okay. Fine. So as we have done previously, these are the different pipes and the losses, and today we are going to see how we are going to integrate together. And now, furthermore, before proceeding with the utility of this head losses, and majorly what we have seen in the last class is that the losses of pipe, and due to friction, that was a major part that we have covered, and a bit of a simplified problem that we have seen, how if we are magnifying this like if we are enlarging the pipe or if we are contracting the pipe, so how to solve the problem and what are the different formulas and to proceed further, right? Now here what we are going to see here in this particular problem, that so first thing is that what if there are two tanks here, one is a tank A and tank B. So and water is fetched in both the tanks, and this both the tanks are connected with a different types of pipe. Okay, so further these are tank A and tank B, and we have two more pipes, that is a pipe 1, pipe 2, and we have pipe 3. Fine. Now we are as in a given problem for your exam point of view, right? So the two the distance between this head, okay, this is called as the end surface layer. Okay, end surface layer. So distance between the two end surface layer, if I measure, that is called as a h. Here that you might get confused most of the time. Sometimes h is been mentioned as an head loss, and sometimes h is mentioned as an difference of water level in the two tanks. But here keep in mind that here it is defining as a difference of water level in the two tanks, right? Understand this nomenclature because this is going to help you when you are solving a problem, right? Now next we have this two tanks are connected with three different pipes. See, in the pipe 1 it is coming, so what happens from this big tank A, the water is entering into the pipe 1. Fine. So water is entering, as we have listed down the different types of pipe, that is different types of losses, major losses and minor losses. So entry into the pipe or entry of fluid into some other object, so that also creates some kind of minor losses. So entry happens, right, in the inside of this tank A and the between the pipe 1. Now see, another portion is in between the pipe 1 and 2. So what happens, the pipe 1, the D1 is larger than D2, right? So there is some changes, and what is the changes? All of a sudden the D2 get contracted. Then again you see the differences, that that from the fluid, okay, what is happening here between the 2 and 3, what happens, the D2 is less than D3, right? So D3 is larger than D2. So here what happens, expansion. But each one of this individual pipe, three different pipe, is undergoing a major friction. And what is a major friction? Is a major losses, and that is due to the friction. Each one of the pipe is undergoing friction, that has been mentioned as F1, F2, F3, and F1, F2, F3 are the coefficient of friction, that already we have covered those parts. Then what is V1, V2, V3 is the velocities flowing in the pipe 1, 2, 3 respectively. D1, D2, D3 are the diameter of the pipes, and L1, L2 and L3 is the length of the pipe. Okay, so this is all about the nomenclature. How now let's see proceed that how if such kind of problem comes, how to solve it, in a simpler manner, and how we can obtain here most of the cases our main target is to obtain the difference of head or the head losses, right? The difference of water level or the head losses, that is our moral of the story. Okay, now the first thing, as you know, if I consider only between the pipes, between the first, second and third, we know we can apply a continuity principle on this flow. So we know that very well that what is a continuity equation? Continuity. What is a continuity equation? Right? So that is a mass flow rate entering into the pipe is equal to the leaving from the pipe, and we can say m dot is nothing but rho AV, and we can also say in that the discharge is same, that is an area into velocity, right? So now for each three pipes we are telling that discharge is same, discharge is going to be same. So A1 V1 equals to A2 V2 equals to A3 V3. Now this is fine. Now next thing is that the difference in liquid surface is equal to the sum of it. Okay, now let's find out that always we need to, what you have to do, this is a very important statement that they have mentioned over here. Okay, so whenever you have this kind of question, that is obtaining total head loss in a pipe, okay, so what is it? The difference of liquid surface level. That means, as I have mentioned here, you might get confused that what is H? H is the difference of water level, or it's a total head loss. So you can understand from here the difference in liquid surface level is equal to the sum of the total head loss. So this is H is nothing but, if I sum up all the head losses, that is the H of it. So this is a very important concept that you can grab it from this particular line. Now let's understand. Now before that, you should also analyze by yourself that what are the different losses that is taking place, right? Now as I have mentioned, so initially what is happening there? Initially the fluid is entering from this this vessel A to this pipe 1, right? So first of all the water is entering. So let's recap previously. So what is the formula for it? See, we have written a formula. The water is entering, it is 0.5 into V square by 2G. Now here as it is entering, of course we will apply the velocity 1. Okay, see here, the first one here is, you have, this is for your entrance. Okay, so why you are writing V1? Because it is entering where? In the pipe 1. So the V1 will be implemented over here, right? Next, this pipe 1 itself have its own frictional loss, right? It have its own frictional loss. So major losses, so that formula. And what is the formula for major losses? I hope you remember. That is, we used to write H of F is nothing but 4FL V square by D 2DG, right? So this is a formula, and as you are finding for this, for respective pipe, just give 1 for 1 suffix 1 for the each domain, right? So this is for the F value for the pipe 1. Fine. Now after that, what is happening? See, there is some interaction happening between 1 and 2. The fluid is passing from pipe 1 to 2, isn't it? So again the fluid is so what is happening with the pipe? Now this is very important when there is a transition between 1 and 2. So of course what is happening? There is a contraction. The pipe is getting contracted. So in between you have to understand what is a formula for contraction. So let's go back. Yeah, the head losses due to sudden contraction. So they have given a statement over here, in case the contraction, that is C suffix C value, is not given, you need to consider this formula. You need to consider this formula, right? So now you see here, right? Can you map it accordingly? I hope you can follow this. So this value is for the sudden contraction, right? Now contraction happened and we came to the pipe 2. Now what is happening again in the pipe 2? The major loss is happening. So again that formula is going to implement it in this equation. So this is again for the friction losses in the pipe 2, right? Now this pipe 2 happened, the fluid is now going to enter in this pipe 3. Now see here again, right? Meanwhile, if you have any further questions, you can drop it. Okay, drop the questions in the chat box if anything you are unable to understand or something like that. So again, from this pipe 2 to 3 it is entering. Now what is happening with the diameter? As you can realize from this figure that D3 is greater than D2, right? So there is a sudden expansion. Let's go back to the formula that we have done previously, sudden enlargement. Okay, then what happens? What is the formula? You see, V1 minus V2 whole square by 2G, right? Let's go back. Yeah, now here we don't have V1 minus V2. Why? Because it is in between the V2 and V3. So it is slightly, it is changed between these two pipes. So V2 minus V3 whole square this. So this is due to sudden enlargement. Okay. This is due to sudden enlargement, right? Now we have to again consider for this pipe 3. So pipe 3 friction loss or the major loss due to this pipe. So this is for the pipe 3. Now after that we have taken the friction loss. The fluid is what is happening? It is moving into another vessel. It is moving back to another vessel, right? It is fluid is entering inside the pipe and leaving from it, okay, into another vessel. So what is happening? Exit. Okay, so exit or fluid exited. So this is a formula V square by 2G. So it is leaving with the velocity V3. So V3 square by 2G. This is for the pipe loss when the fluid is leaving or exiting. Fine. Now you might have a question in your mind, that's a very common question, that ma'am, why we are not considering the exit or the entry part when the fluid is moving from 1 to 2 or 2 to 3, because the fluid is also entering and leaving from this 2 again entering, right? That might be a question. But here we are taking a losses only when this is a entire thing is a pipe, right? This 1 to 3 is a pipe, right? So here the entrance and exit is not discussing when it is entering within the pipe. Okay, so from some vessels or some other reservoir, when it is entering inside the pipe, that is the formula that we are considering. Same thing is applicable when it is leaving from the pipe, not within the pipe. I hope I have made it clear. So understand this, you have to remember this formula well, right? So now, so I hope I have clarified this equation, how we have obtained this. So these are the following this head losses are there, right? So this is the equation. Now in the same type of thing, if there are some values are given in the question, so you can just substitute the values, respective values, and you can obtain the answer, right? Now next part, furthermore let's understand another case. If in the question they have mentioned that neglecting or ignoring the minor losses, so you should know what are the minor losses, you know. So this entrance is a minor loss, this contraction is a minor loss, this enlargement is the minor loss, the exit is a minor loss. So if you cancel off only the existence of the major losses, that is come under the frictional forces, that is this equation, then you will obtain your sum of all the head losses is going to be this. Okay. Now there are another case 2 I can say. If they say consider the frictional loss is also or the coefficient of friction is same, right? So finally you will have this formula. Now you can ask me that ma'am whether we have to memorize this formula. My suggestion will be like no need to memorize it, because it's not we can't say a predefined thing. The question will be like this, so there is no point of memorizing this formula. But yes, of course you should know the process, how actually we have obtained it. You should know how we have obtained this thing, right? Now one thing you have to keep in mind, this all these pipes are in series. This is one condition. Now in future we will also see what if that pipes are in parallel, right? So this is the case that we have referred when the pipes are in series. Okay, so meanwhile if you have any question, please let me know. Okay, meanwhile if you have any question, please let me know in the chat box, right? So let's look into this problem. Okay, see again, before explaining of this particular problem, make sure of that in your final exam point of view, nowhere it is going to mention that from which unit. A mixing of all the units might be there, so you should able to identify the question. That is again and again I am telling you the same thing. Alright, now coming to this problem, determine the rate of flow. So when it is determine the rate of flow means Q, water, that means the density is equals to 1000 kg per meter cube, flowing through a pipe of diameter. They have given one diameter which is 20 centimeter, length they have given is L. When one end of the pipe is connected to a tank. Now you see, so one end of the pipe, there is a pipe, they have given the dimensions and all. One end is connected to a tank, another end is connected open to the atmosphere. Okay, so it is open. The pipe is horizontal and the pipe is horizontal. Okay, so the pipe is in a straight line, that is not inclined, but the height of the water in the tank is 4 meter above the center of the pipe. Okay, so if it is kept horizontal, so figure is not given in this question. And one more thing they have given, consider all minor, consider all, they have asked to consider all the minor losses, right? So we can't ignore the other things, we have to consider it. And take F equals to, they have given the F value. So now one more important point to take away, if the F value is given, you don't need to calculate it, because as of you know this formula is concerned, that is for the major loss, right? So so how is to find F? F is dependent on the Reynolds number. If it is less than 2000, there is a formula. If it is greater than 2000 or 4000, there is a formula. So as this in this particular problem the F value is given, you don't need to obtain the Reynolds number. So simply you can ignore this part. Fine. Now let's focus on to this. Now first of all, in this problem it is very important to make a layout. So if there is a tank, okay, there is a tank, and the tank and a pipe is connected, and they have said the pipe is horizontal, and from the center line of the pipe and the water is around, so till here water is there, the surface of the water, right? And of course this, oh, all right. So that's very important to draw the figure. Okay, so water is going from this way right? This is a pipe, one end is connected with the tank, one end is free through the atmosphere, right? And this length is given, length is 50 meter, D is around 20 centimeters, so which is around 0.2 meter, right? If somewhere I go wrong, please you can drop in the chat box. Okay, and as they have asked what should be the value of Q, they have asked, right? And then pipe end atmosphere. Okay, so this H value, right, they have said it is from the center line of the pipe and this height of the water that is in the tank, the distance between this is that is the H, right? So that is a 4 meter that is given. F is given, friction 0.009, there is no unit, fine, and consider all losses, right? So before proceeding, so how to find all losses? So first, what are the losses it's happening, that is the important part to identify what are the different losses that is happening. Okay, one losses is happening is from when the flow is entering over here, right? As I have said, from tank to this pipe, so inlet, this pipe, that is the entrance of it, one loss. Then one is a major loss, that is H of F, I can say that is a major frictional loss is happening, then any other losses that you can identify from here, let me know in the chat box. Can I say there is another losses when this water is leaving from here, right? After the water is flowing, where it will go, right? It has to leave it somewhere from there, right? So when it is okay, when it is leaving, just a second. So basically in this particular problem, exit, fine. Now let me give you the procedures. So what is the like how you can obtain this? So sum of all head losses is what? The sum of all the losses. One is the exit, then your friction, then entrance, friction and exit. Okay, now what is the formula for entrance? Entrance is 0.5 V square by 2G, exit is V square by 2G. Okay, so you can simply write over here, one is 0.5, so entering is, there is only one V, right, which is happening, or the velocity which is inside the pipe. Okay, let me write V. Okay, 0.5 V square by 2G plus here we have 4 into F value into L into V square by 2dg, right, plus exit is V square by 2G, right. Now here it is very very important, what is the value of V, because here nowhere it has been given, because if I see the given data that has been given from here, F value is given, L value is given, D value is given, G is given, right, G is constant basically, but V value is not given. On the same side, at the other end, Q value they have asked that to obtain it. So the major challenge over here that you will face, that how to obtain. So may I know any guesses? How can we obtain it? Any guesses that how we can obtain this value? Any guesses? How can we obtain? Let me take you back here. Okay, fine. See this statement, as I've said, the difference in liquid surface level is equal to the sum of the total head loss in the pipe. So same thing is going to be implemented over here. So here the difference is the H value. So the H equals to this 0.5 V square by 2G plus 4FL V square by 2DG plus again V square by 2G. So we will substitute the given data. So H value is here is 4 equals to, and whatever the value will get, some parameters by V square will get. So that is the only thing unknown. So from there we can obtain the value of V. Now according to the continuity equation, you know that Q equals to A into V. So once we obtain the V, we know the A is area, we know the diameter, that is Q equals to pi by 4 D square into V. So this value is known. So from this equation we will know what is the value of V. So we can find the Q value in terms of meter cube per second. We can find out in terms of meter cube per second. Let me see. Kindly tell me that if you have any doubts or not. It's clear or not? If not, please let me know. I should change the color, I guess. The color is very light. Is it clear? Just write in the chat box yes, no, or I hope you all are watching and understanding the lesson. Because again, when it comes to end semester, the same question is not going to come in a question. And this is one of the very scoring part. Okay, I believe that you have understood. Okay, so again this is a similar kind of problem. Here there are multiple ways to solve it. So you can also try that in the same way. And here the most challenging thing that you should keep in mind is that that is the formula. That is the most challenging part over here. Now again let me read and give you the briefing how to solve it, just outline. A horizontal pipe line 40 meter. So there is a horizontal pipe of 40 meter long. So L is given, is connected to a water tank at one end. So one end and discharges freely into the atmosphere. Okay. So it is the water is coming out from the pipe at the other end. Okay. For the first 25 meter of its length from the tank, the pipe is 150 diameter and its diameter is suddenly enlarged to 300 mm. Okay. So the total length of the pipe is, if there is a total length of the pipe is 40 meter long, and out of that the first, that means if there is a tank connected over here, the first 25, that means from here to here 25 meter is your length of it, and the diameter of this is a D is 150 mm. Okay. Then suddenly what happens, after this 25 suddenly enlarges, so that means it is no longer the same, it is enlarging to some, rest of the thing is something else. and which is around D changes to 300 mm. Okay, suddenly enlarges. So we have D1 and D2 we can say, and L1 and L2. So of course what will be the L2? The 40 minus 25, whatever the value, that is a 15 meter is your L2. The height of the water level is level in the tank is 8 meter above the center line of the pipe. Okay, so if I draw a center line of a pipe from here to this, water level is between this is a 8 meter. So basically we have the head. Okay, head of the water is 8 meter above the pipe. Consider all the losses of the head which occurs and determine the rate of flow. Okay, so again here the same type of question. They ask the Q value, they ask what are the head losses, consider all. So here the major challenge is that you are taking the right losses that is occurring inside the pipe. Again see here the F value is given, and what they have said, take F value equals to 0.01 for both section of the pipe. So the section irrespective of whatever the section, the friction, the coefficient of friction is remain same. So here F1 equals to F2 equals to F, which is same 0.01 value. Fine. Now again let's understand this problem. Let me I need to draw it again, because if I draw like this it will be hard to understand. So according to the problem statement, from the first 25, that is this one, the diameter they have mentioned here, the diameter they have mentioned over here, right, from here to here. After that what happens, it is getting enlarged, it is getting enlarged, okay, whose diameter is D2 and L2 becomes 15 m. So according to a given data, so we have one pipe, so pipe 1, pipe 2, and this is a tank, tank A you can say. So first of all the water is passing from tank A to pipe 1. So what are the losses? So identify the losses. Okay, the first thing, when there is a transaction between tank A to 1, okay, so there is an entrance, right, losses due to entrance of fluid. So losses is there, that is how do we define H of E. Okay, now water entered inside. Now the pipe itself have its major losses, that is a major loss, that is you can say frictional losses. Now once the pipe is from the pipe A, it is leaving to pipe 2, 1 to 2, it is leaving 1 to 2. What is the factor that is happening? There is a sudden enlargement. There is a sudden enlargement. So sudden enlargement, H of I, entrance is H of I, and according to the bookish definition it is an H of E. Okay, so anyways, understand the formula and do this accordingly. Now there is a sudden enlargement, okay, because from D1 is 150 and D2 is 300. Now within this pipe 2 you have a again major loss, that is a frictional loss, and from 2 to exit, what is happening? The fluid is leaving freely or discharging freely, so you have the losses due to exit. So that is, let me write H of exit. Okay, so how many? 1, 2, 3, 4, 5. So you have 5 losses. So when you are obtaining an equation. So when you are obtaining the head losses, right, head loss is nothing but the 8 meter, that is same as the difference of the water level. So 8 equals to h of I, that is the entrance, h of the F1, that is for the frictional loss, plus h of E, that is a sudden enlargement, then h of F2, then h of exit. Okay, so here you have V1, here you have V2. So make sure of that when you are solving this. Okay, so what is H1? Entrance, that I think previously we have seen, entrance is 0.5 of V. So you can write here, sorry, here you can write 0.5 of V1 square by 2. Okay, then here you can have to write the normal formula. So previously the formula was given in this question, but here it is not given, so you have to memorize at any cost. So 4f L1 V1 square by 2 D1 G. Because here I am writing f, because here in this given question the frictional the coefficient of friction is same. Then exit, the sudden expansion or enlargement. So let me check the formula. Enlargement, sudden enlargement formula is V1 minus V2. Okay, so this is the formula. So here you have V1 minus V2 whole square by 2G. Fine. Now again you have for the next frictional major losses, that is 4f L2 V2 square by 2 D2 G, plus exit is V2 square by 2G. Fine. So this becomes your formula. Now here previously you see you don't had much of the challenge, because here just a second, here you had the h value, here you have only the v, only one unknown over here. But whereas in this problem the major challenge is that you don't have a single v, you have the unknown is a v1 as well as v2. Here the major challenge you will get and the face is that v1 and v2. So how you are going to solve this v1 and v2? Because in this problem you don't have it, you don't have the here you don't have any other thing, right? So you can use a concept of continuity equation. What is it? A1 V1 is equals to A2 V2. Now if I take this particular portion, that is A1 V1 is equal to A2 V2, right? Can I make some relation in single term? Like can I write A1 by A2 into V1 is equal to V2, right? So if I substitute the value of A1 and A2 and A1 and A2, so I will get some value of with the V2, maybe some x term of V1, right? Some x value of V1 I will get. So in this equation, right, can I substitute the value of V2 in that some x value of V1? So what happens to my this entire equation? The entire equation get converted in a single term. So I can find either V1, however you change this, I can get any one of the velocity. Now once I obtain any one of the velocity, I switch back and substitute to this equation, here in this equation, then I get my answer. So what is the V1 value and V2 value, right? So I prefer this is one of the simplest way to solve it, right? And this is a procedure how you have to proceed. In this particular chapter, the major challenge is going to be your to identify the losses. to identify the losses. And similarly, this is the very simple problem, and you can practice initially with this problem, right? And next, coming to this kind of theoretical part, this is very important, understanding the concept of hydraulic gradient line and the total energy line. So this is nothing but the datum line, how we are representing mathematically, and what are the constraints, and from where do we measure, how these lines are different with one another. So this is a theoretical part. I will suggest you to you refer by yourself this theoretical portion. So I am skipping this as of now. Okay. Okay, now let me give a brief of this outline. What is the equivalent pipe? Sometimes in 2 marks, or you used to get in numericals about the equivalent pipes. So it's nothing but, as of now, whatever the things that we have gone through, so it's all the same about the equivalent pipe. So basically what happens, let's understand this portion. This is defined as a pipe of uniform diameter. The diameter is to be uniform, having a losses of head and discharge equal to the losses of head. Okay, and discharge of the compound pipe consisting of several pipes of different length and diameters, right? So if you have a uniform diameter with the same head loss and the discharge, which must be equal to the discharge of compound pipes consist of several pipes with a different length and the diameter. Okay, so this is the understanding that what do you mean by equivalent pipe. Uniform diameter of equivalent pipe is called as the equivalent size of the pipe. Okay, now here the major challenge that you can see, the length of the equivalent pipe is equal to the sum of the lengths of the compound pipes consist of different pipes. So total head loss in the compound pipe are, so in this case majorly what is another assumption that has been taken here in equivalent pipe is that the minor loss is neglected, only the major loss is taken into the consideration. Okay, and assumptions has been taken that whatever the pipes might be, whether you are using multiple, you have 4 pipes, 5 pipes, irrespective of whatever the diameter might be, so the friction losses are going to be the same. Okay, so if it is same, so we will get to this. So this is an understanding of this equivalent pipe concept. Okay, so what is it? So if you have a single pipe, and another side you have a multiple different types of pipe, like all of a sudden there is a sudden contraction, then again expansions, and it goes on, right? Whether it's a enlargement or contraction doesn't matter. But if their head loss and the discharge is same, right, for a single pipe or the compound pipes, so then it becomes a equivalent pipe. This is the understanding from this statement. Okay. Then moving to this another concept is a flow through parallel pipes. So till now what we have seen is only the series pipe. Now here, as you can see, what if it is getting branched? Okay, what it is getting branched. So today we will finish off this particular topic. So let's focus into it. So what is it? How actually it works? It's because both the principles are same. Only things that how to implement and all that only will be different over here, right? Now see the flow through parallel pipes. Here the main thing is that what we are going to see is the flow through parallel pipes. Now you see in this diagram, right, there is one main branch. Okay, the fluid is entering from this main branch and it is splitted in two. Both are moving parallelly. The diameters, length and the velocities are also getting splitted. Branch 1 pipe and 2 pipe, you can see the length of the pipe is L2, diameter D2, V2 is the velocity, L1, D1, V1 are the length, diameter and the velocity for the pipe 1, and these are the for the parameters for the pipe 2. And finally what is happening, these fluids are again merging in one point and passing from it. Okay, now again and again I am telling, in your end semester point of view, you have to identify from by reading the question that how to obtain it, or which it has been asked from which chapter. So whenever some relevant questions are coming up, so you should keep in mind always three equations are going to play a major role over here. One is a continuity equation, that is Q equals to A1 V1, okay, A1 V1. Then is a, make sure whether any datum line is playing a major role or not. If it is coming, then Bernoulli's theorem or equation will again come into the picture. And the third one is the losses. If there is a sudden expansion, if you see somewhere some f value is given or mu value is given, make sure of that some sort of losses are being involved in it. Okay, so these are the key points that you have to look into it in this corresponding units. Now moving forward, that how we can solve. The major objective of this problem is to find out the head losses or find out the some one or other losses and all. Now as you know already from the continuity equation, if this is a scenario and this is a fluid, so of course the Q is going to be Q1 plus Q2, isn't it? And or if I say Q1, if I say Qi, and this is Qe. So Qi is equals to Q1 plus Q2 equals to Qe. I hope you believe in this, because this going to work on this continuity equation. And the same thing has been mentioned over here. Now in this arrangement, the major thing or the key points to take away is that in this arrangement the losses of head for each branch pipe is same. Okay, this is a key point. If you understand by reading the question that both are parallel or they are branch and moving from one point to another point, this is a key point. The losses of head for branch 1 pipe has to be equal to the pipe 2. See, though their L1, D1, V1 are different, L2, D2, V2, but still the total gross head losses are going to be the same. This is one of the very or you can say one of the key points in this flow through the parallel pipes. Right. Now if I have to say, and again in this kind of conditions, right, if we are ignoring the minor losses, only considering the major losses. So if I have to write H of F1 has to be H of F2, right? H of F1 has to be H of F2. So we know the formula for FL V square. So 1 here also 1 by 2 D1G has to be 4 F2 L2 V2 square by 2 D2G. So this thing will get cancelled off, G will also get cancelled off, right? So if see here, if F1 and F2 is also same, if the friction, the coefficient of friction is same, so we can solve the numericals using this. Okay, now this is very hard to understand if I just overview it. Now let's look into a real time example. So that will be, that will help you to clarify the, how to proceed with the numericals and all. So as you can see from this question, okay, before seeing it, let's read the question first. Let's see whether really it's belonging from this particular topic or not. Okay, all right. So a main pipe divides into two parallel pipes. See, the first statement itself, it is given like it is divided into two parallel pipes. I hope you all are able to understand this, because I can't find any responses till now. All right. Okay. As you can see again, the first thing that is that a main pipe divides into two parallel pipes. Okay, the main pipe is divided into two parallel pipes. So from here you can understand, from the main pipe it is dividing into two parallel pipes. Fine. Okay, two parallel pipes, which again forming a one pipe. So as we have seen just now, which again merging all into a same one. Okay, merging into a single pipe. So here is our QI and QE, this is Q1 and this is Q2. Okay, acha, here in this I have not seen it. Okay, figure is given. So anyways, the length of the diameter, the length and the diameter of the first parallel pipe are, they have given. So length, if it is a 1, so L1 is our 2000 meter and diameter is 1 meter. Okay, because the first thing is given as a length, so this will be our length. Second is a diameter, so this will be our diameter respectively. Where the length of the diameter of the second parallel pipe is, so L2 is also same 2000 meter and D2 is different, that is 0.8 meter. Alright, so again they have given. So this is L1, this is D1, this is L2 and this is D2. Find the rate of flow. So again the Q in each parallel pipe, if the total flow in the main, okay, so total flow they have given in the main, that is a QI. Okay, QI is 3.0 meter cube per second. That let me consider that. And the coefficient of friction for each parallel pipe is same. So F value is same for all. Okay, so there are two different pipes, F value is same for all. So now how can I proceed? The main challenge over here is to find for each pipe. That means I have to find for Q1 and Q2. That is a challenge. Now to find Q1, so of course we need A1, V1, and to find Q2 we need A2, V2. Now here we know what is A1 and A2. A1 and A2 is known because we know the diameter, but we don't know what is unknown is a V1 is unknown and V2 is unknown again. Now how can we proceed? Very easy. So can I say, according to these are the words, you have to mention it according to the continuity equation. So this is a simple problem, you can say, using continuity, but yes, you have to identify this using this frictional value, because here the F value is given. Okay, so Q equals to Q1 plus Q2. I can simply write this statement, and we know what is Q1, it's 3. So here I can write A1 V1 plus A2 V2. So I can also rephrase this equation, this 3 equals to pi by 4. Our D1 is 1 square into V1 plus pi by 4, it's 0.8 of square into V2. So this becomes my equation, something like that. And so V1 plus 0.8 square of V2, so here it becomes 12 by pi. I get something like this, right? So basically I have two different parameters, that is V1 and V2, right? Now how to obtain this value V1 and V2 again? So as it is a problem where it has been stated a frictional force, so here what we have seen in the previous statement, that so in this, if the pipes are parallel, the head losses are same. So what are the head losses here? So as we know, according to the given question, the pipes are parallel. Okay, so head losses in pipe 1 is equal to head losses in pipe 2, right? So HF1 is equal to HF2. So if I have to rephrase that again, 4F L1, L1 and L2 are both same. So let me write in the same way. V1 square by 2dg, right? D1, let me write D1, and here F4 FL, because both are same. Here V2 square by 2d2g, fine. Now here can I cancel off the common terms, because as per the given question, this thing from 4 4, here 2 2, here F, because it's same as per the given question. L is also same in the given question, G is also same. So what I can obtain from here is that V1 square by D1 equals to V2 square by D2. Okay, so V1 by V2 whole square is equals to D1 by D2. I can write. So this is one of the particular subject, or you can say this particular topic. Many of the times, in the GATE question paper, you can find this type of questions on the relation basis. So if you know the value of D1 and D2, so D1 is 1 and this D2 is 0.8, square on means root over V1 by V2, you get to get some relations between V1 with respect to this. So once you have one of the unknown parameter, what you can do is put back in this equation, solve this any one of the parameter, and again you can resolve it. It's a very simple form of solving this kind of problem, right? So I hope it's quite easy for you to understand, and likewise there are a lot of problems you will be finding. And as you can see in this type of problem, a pipe of line so and so increasing, so there are different cases. One case you have to find this, one other cases you have to find other thing. So the moral of the story is same, but you have to identify the problem that is a major challenge over here, right? Now in this particular problem, let me give you a hint. Here they have given a unique styling of giving no frictional force, that is F equals to 0.04, 4F equals to 0.04. so find F is 4 by 4, right? So you can find what is actually F, right? So indirectly they have given. So such kind of problems are you can expect in your end semester, or if you're preparing for GATE also, you can expect such kind of questions, right? So I guess that I have covered up my best of this particular unit. So we have given an overview, the parallel plates, how to resolve, understand the concept of it. Meanwhile, if you have any question, you can drop in the chat box. I will clarify your doubt. You can just, if you can't explain each and everything, just give the hinting points also. I will just recap. I will try to recap. If it is a very small thing, I will try to recap that. Okay, and yes. So understand the problem that flows through parallel pipes. So what are the conditions of how to implement it? Because this will make a difference in your answer. Then what are the definition, especially majority of the end semester paper or some of the MCQ, they are asking the definition about the hydraulic gradient line and total energy line, how they are different with one another. So for the exam point of view or for end semester, this is one of the important, very very important part. And yes, as I was discussing that how to resolve it, you should understand what are the losses that is actually taking place. And yes, talking about this, you can also expect a combination of flow where it might be both a series and parallel. So understanding the concept and implementing the unknown factor. So likewise, there are a lot of problems are available in your textbook. So please do recap and practice for your end semester point of view. So the major challenges that students face is that memorizing the formula or applying a wrong formula. So make sure you know all the formulas at different scenarios. That means if there is a head losses in various pipes are fitting, bend of pipes, losses at the entrance of the pipe, exit of the pipe. So there are different cases that already we have discussed in some of the points in this class as well as in the previous class. So please go through it thoroughly And meanwhile, if you have any doubts, again and again I'm telling, just drop it in the chat box. So this unit, we are done with this unit, so make sure of that you have a good hold on this particular unit, and this is really a scoring unit, right? So next class we'll be seeing a boundary layer thickness and its implementation. Fine. And that is also one of the like easy part. Okay, let me wait for a while. So if you have any question, just quickly write in the chat box so we can discuss it. And let me see the attendees who are all attending it. So drop your name in the chat box. I can see only 2 names in the chat box. Who is Dreamers? Okay. I hope you don't have any doubt. Then shall we wind up the session then? Okay. But who is Dreamers? I can't find. Anyways, I hope okay. Fine. Alright then, I hope you believe that you don't have any doubt. Then let me wind up the session here. Thank you and all the best for your exam, and see you soon in the next class.